Hello everyone, welcome to GATE Digital Electronics PYQ series. So in this series we are gonna solve previous year questions from GATE. So it will help you in preparation for GATE. So today we are gonna start with digital electronics and here are some questions. So the first question is, so I'm taking these questions randomly, not topic wise, so that it will help you to understand topics. I mean, it will help you to prepare for GATE exam. And today this question is asked in GATE 2023. So here what I am given is the synchronous sequential circuit shown below works at a clock frequency of 1 GHz. The throughput in mbits per second and the latency in nanosecond respectively. So we need to find the throughput and latency. So here we need to remember the units here we need to find in mbits per second and latency in nanosecond. So when we observe this diagram, so the circuit, so we can see that this is a serial in serial out shift register. So here we will try to find the latency. So in order to find the latency, first we need to find a T clock period. So first here we are given f clock is equal to 1 gigahertz. So when we convert into hertz, that will be 1 into 10 power 9 hertz. So now we will find T clock. We know that T clock is equal to 1 by f clock. That will be 1 by 10 power 9. That is equal to 10 power minus 9 seconds. So when we convert into nanoseconds, this will be 10 power minus is 1 nanosecond here. So in order to find latency, so here we find latency. So here we are having 3 flip-flop. So for 1 flip-flop, we are having 1 nanosecond latency. So here we will have 3 into 1 nanosecond. That will be 3 nanosecond. So in order to, so here we are given, we are getting answer latency as 3 nanosecond. So we here we will eliminate by this we can see. So this option is eliminated. Now for all these three options we are having 3 nanoseconds as answer. Okay, now let us find the throughput. So in order to find throughput, what is throughput? Throughput is number of bits per second, number of bits processed per second. So here we are having 1 gigahertz frequency. That means here we are having 10 power 9 bits per second. So 10 power 9 means that is 1 GB per second, 1 gigabytes per second we are transmitting. So when we convert, we need to know that throughput in mbits per second. So when we convert this into mbits per second, so 1 gigabyte will be 1000 mbits per second. So this answer, the throughput will be 1000 mbits per second. So this is the answer here. 1000 mbits and 3 nanoseconds. So we will verify which one we are having. 3 bits and 1 here, 1000 3 and 1000. So this is my option A is correct answer for this question. So coming on to the next question here. So here in a latch circuit, say in a latch circuit, so the NAND gates have non-zero but unequal propagation delay. So keep in mind here unequal propagation delay. The present input P is equal to Q is equal to 0. So here we are having P is equal to 0 and Q is equal to 0. So if the input condition is changed simultaneously to P is equal to Q is equal to 1, the output section by R. So what will happen if my input is changed to P is 1 and 1? So when you if you have studied SR latch using NAND gate, so this is an SR latch, but we are replacing S and R with P and Q here. So here when we observe here, this one we are having when both are 0 for NAND SR latch, X is equal to and Y is equal to 1. So 0 and 0 it will be 1 and 1. So please understand here, this is for NOR it will be no change. For NAND latch it is 1 and 1, that is invalid state. So now what we have to do is we are changing this to 1 and 1. So for 1 and 1 it will be no change state. So but here we are getting unequal propagation delays. So for these NAND gates we are having unequal propagation delays. Let us say that this one is TD this gate is having 2 TD, and let us suppose this is having 2, and we are assuming that this is having lesser delay compared to this. So here my this gate will give my output TD times faster than this one. So this gate one will, this, let us say this one as this gate one delay is lesser than gate 2 delay. So here my output here will be 1. So 1 into 1 will, I will get 0. And here this will remain 1 for when this will be for one case it is x is equal to 0 and y equal to 1. So for another case this will be, let us assume now for this one we will assume, we will take another case where gate 2 delay is lesser then gate 1. So let us take this one is 2 TD and this is TD. So here my output will be 1 for 1. So then I will have 1 and 1. Then this will be 0 and this will become 0 will be transmitted to here, and this 0, 1 into 0, and this will again become to 1. So here my x is becoming 1 and y is becoming 0. So in options, if you will be given either x is equal to 0 and y is equal to 1, or x is equal to 1 and y is equal to 0. So this is the correct option for this one. And next, so this is another question, and this is also 2017 GATE EC question. So here we are given, consider a D latch shown in the figure, which is transparent when it's clock input. So I forgot to give the diagram here. So I am drawing this diagram here for this question. I'm having this one. This is my one clock. So this is a D latch. Remember that one. So I am having, this is D input and this one is Q. And Q here, and this is my here input clock as represented at CK. So this will be my CK2 and sorry CLK2, and this will be my CLK1. So I am giving this one this waveform here, and this waveform I am giving here. So here when we see here transparent latch, when clock input CK is high and has 0 propagation delay, then we are assuming this latch is having 0 propagation delay. So when you are giving input, that time only you are getting output. So as 0 propagation delay in this figure, the clock signal, clock 1 has 50% duty cycle and clock 2 is a 1/5 period delay. So here having clock cycle means 150% clock cycle means half TCLK on for on period and half TCLK for off period. This is for CLK1. And now what is the condition given here? CLK2. CLK2 is 1/5 period delayed version. So it is 0.2 CLK1. So here what I will do is I will simply, here 0.2 means that will be 0.5 TCLK. So I will simply subtract 0.5 minus 0.2. That will be 0.3. So in aptitude, if 0.3 means that will be in percentage, that will be 30%. If you shift 2 decimal points, so that will be 30%. So the answer is 30%. This one. So the duty cycle will be 30%, which means in order to understand this will be on for 30% of duty cycle. So that is the question they are asking. So that's all for this video. In next video we will come with some more PYQ question. So stay tuned and subscribe to our channel. Thank you.